Good morning. Welcome to the 7th meeting of programming with psychologists. We will be speaking about structures today. Structures are a new way of representing data in MATLAB, a new for us, new way to represent data. And it's a more complex data structure. It's a way to lump parts of information together that belong together. For example, I have an example here where I create a musician with a name, Dr. Dre. He sings in a band and he is a member of that band for a couple of years. So in this, the way to address this is with the dot notation we saw before. So we have a musician, that's the structure, and each of the fields, each of the information parts of this structure can be represented with a dot and then the name of the data that it represents. For in this case, it's the name, it's the instrument, and it's the years. And we can add these musicians into a new container, which is a band. So we make a band, and the band has, as a structure member, the structure member, which is the musician. Another way to define a structure is with name-value pairs that we also used in the in the plot statement. Then you start with the keyword struct, and then you have these couples of names and values. So in this case, we get the same type of structure as before, with a name, with an instrument, and with a year. In this case, this musician represents MC Ren, who is also a vocalist in a band. So that gives us two different ways to define a structure. We have the dot notation and we have the name-value pairs. The way that you select the variable names is the same as we saw before in other variable names. So you can't start with a number, but you can use all the other characters. We will try to get some new band members. We add the MC Ren, first we add MC Ren to the band. And if we now look at what band looks like, it's still a struct. It's a one-by-one struct. A musician also is a one-by-one struct, but we can see that by adding this musician to the band, we didn't overwrite the musician that we had before. So Dr. Dre is still in the band. So if we look at what the band looks like, you can see it now has two members. It's a 1x2 struct with a Dr. Dre and MC Ren in there. So if we grow our band by adding Ice Cube, and DJ Jella, Professor X, and we add them all to the band, you can see that band is still a one-by-one struct because we have one band, but the band has now 5 members. It has Dr. Dre, MC Ren, Ice Cube, DJ Jella, and Arabian Prince, or Dr. X. Having these musicians in a band does not define the band at whole. Musicians are, in this case, just one of the fields in the structure band. So we have a structure in a structure. But a band also has a name, a single name. So if we give this band a name, you can see that band still is a one-by-one struct because we have one band. But if you look at the way the band is structured, you can see it has 5 members and one name in there. So that's interesting, and that's a way to lump the information that what we're interested in together. You can imagine that creating a database-like structure like this band is very interesting also for doing data analysis and looking at data that come from psychological experiments. The elements of the structure can be addressed using the dot notation, so you can also display the band's name just by using band.name. And you can select band members by just asking, for instance, to give, in this instance, I ask for those members of the band for which, if you compare the name with Dr. Dre, it gives a true. So it selects Dr. Dre from the data. So if I run this, you can see the information that belongs to Dr. Dre. You can be aware that you have to lump the band members together with square brackets here, because if you just ask for band.members.name, I will do that here, band.members.name, you will have this very weird output from MATLAB, which takes some time to get used to when you're a programmer used to other programming languages. And that is, you have multiple answers to the same query that we give here. So we get answers for each of the elements, we get the names, but to lump them together, you need to put square brackets around them, and then you get a 1x5 string array, and which you can again index to the numbers. So that's what we do here. You can ask which fields are in a structure with the keyword fields. So if you do that, it will tell you it has members and it has a name. The band has members and a name. And if you look at the fields of the, if you look at the band members, you see they have a name, an instrument, they play an instrument, and they are a member of the band for a couple of years. The fields can be anything, and you can combine all the elements that you want within structures. So it can be strings, it can be vectors, it can be matrices, it can even be structures, as we've seen in the example of the band. Okay, now how are we using structures in MATLAB when we want to do data analysis? I'm going to assume that you know about the Stroop experiment. So let's assume that we have data from a simple Stroop experiment with congruent and incongruent trials. This data file will probably include information on the participant level, so the information about the participant, for instance, its number, the left or right-handedness, the sex of the subject, some of the demographic information on the subject, but also information on trial basis. So trials that can be congruent or incongruent, part of the practice block of the experiment or the experimental trials, and information on whether the trial was indeed congruent or incongruent, the reaction times belonging to each of the trials, and the information on whether the subject responded correctly or incorrectly on the trials. Those are the standard things that you need to do an analysis on a Stroop task. So we can look at these data files by importing them into the workspace, by going into the Stroop data and copying them, well, not like that, like double-clicking them, and then we can look at the data like this. So you get the load function, and you can see that in the data in your workspace, then a new structure named data occurs. That is one of the drawbacks of using load and save as a way to save your data and load your data. When you use save, it is unload, it's quite quick, but it saves variables. So in this case, by loading it, I'm not able to change the name of the variable that I load in because it was defined at save time. So the data that occurs here is never mentioned in my MATLAB code. It was mentioned when the people that saved this data saved the data. So it's very important to look at the names that are in the mod files that you import. Okay, I'm going back from the strup data directory now, because the better way to load these is not to go directly into the directory and click the data, but by using the load command from your script. But then remember that you don't know what name the data got, so always check. So if I run this, I said when I run this, why can't I run this? I'll try it again. Evaluate selection. You can see that the data in this case is a structure, and it has several fields. It has the information on subject level, so the name, the number of the subject, the age of the subject, the gender, and it has four fields that are based on trial levels. So it's the congruency, which is 420 values of congruency, 420 values that represent reaction time, the correctness of the data, and the type of data. So that is the information that is in the data for one subject. So if we take a quick glance to what, for instance, the congruency data look like, we can evaluate that, and you can see that they are cell structures which contain character arrays. So they can be congruent or incongruent. If you look at the age field, it is just a single number, so it's an integer, and it represents the age of this individual subject. But if you look at the response time, you can see it's a list of response times, so it's numbers. You can look at the fifth response time just by indexing like this, like any vector, it's because it is a vector. And you can, depending on the data type of the specific field, use all kinds of functions on these fields. So if you want to know the mean reaction time, the way to do that is just call mean. We will go a bit more nuanced on that later in this tutorial. If the data set is, if the data that you are looking at is not numerical, you can use, for instance, string compare. In this case, you can look at the congruency by saying, by comparing the data congruency field with a string, and then you get the logical values for true or false. So you can add a field to the data if you'd like with the dot notation. So I will create a logical vector here called isCongruent, which does the same as the previous value, and what it actually does is it adds to the data a field called isCongruent, which is true if the data, if the congruency field holds the string congruent, and if not, it will be false. So if you do that, you can see there's another field now, isCongruent, which has the data in a logical shape. So that's good later. So if you want to know what the reaction time is on the congruent data, so the congruent trials, you can use the previously defined variable congruent as an index to the reaction time field. And in this way, it would be 500. Of course, this congruent will only be available if you just ran this command. If you have only ran this command, you can also change congruent here by data is congruent, and you get the same value because you do the same. I hope that is clear. Now, if we run the load statement again, and now on the second subject data, we say stupid, stupid MATLAB, because what MATLAB does is it overrides the data field that we just loaded in, because in this mat file, again, the data is stored in the variable named data. So this is why I say stupid, stupid MATLAB. It is at least something that you need to realize. It is possible to create the structures and create a matrix of structures by saving the data variable into a vector of data, a vector of structs, based on the data that you previously read in. So you load the data, which creates a data structure. You save that structure, and then you load the new data, which again will be named data, and then you save that into the new part of the data. So if you run this, if you evaluate that selection, you have data all, which is a vector 1 by 2 of the type struct. So there are two structures in there. So if you look at that, you can see that they are subject, age, congruency, they are all lumped together again. Okay. So you can index data all with the subject number, and then you can look at all the elements, all the information that is available in that structure for that subject. And you can, of course, continue and adding to that data by looking at the next and the next and the next subject. In this case, it's the 7th subject, but in the task that you will be doing, you will have to read in all the data. Okay, I hope this is a bit clear now. So what you will be doing when you're doing data analysis for a large part of the programming that you're doing is trying to get your data in a form that allows you to do the analysis most elegantly or most easily. So one way to do that is, for instance, make a matrix that contains all the response times for all your subject data. So you can do it like this. If you do that, you can see that you have a response time matrix for all the 3 subjects that we have. And if you look at the data, you can see there are 3 columns and then 420 rows of response times. So that would be ideal for analysis. Another way to do that, if you want all your data in there instead of indexing them separately, is by leaving out the index altogether and then put square brackets around it, just like you did here. So you get the multiple results again that we saw before, and you lump them together like that. You get the same 420 by 3 matrix. But matrices are a bit restrictive in MATLAB. In this case, it's ideal because all subjects have 420 responses to the trial. Because matrices, all columns should have the same number of elements. That's something that is very rare in data sets. You have missing values, you have tasks that run for a certain amount of time, and all kinds of elements. It's very rare that you have exactly the number of trials, the same for each subject. in this example, we do have them. So you can assume in your task that you will be doing later that you will have the same number of subjects. So you can make a matrix of this. So this assumption that we have on the length of the data allows us also to create a loop to load in the response time data as a matrix. And this, of course, in this example, I take the response time, but this, of course, holds for each field of the data that you get from the load statement. In this case, I create a list of subjects that I want to load in, subject 1, 2, and 7, the ones that I read in before. And then I have a loop where I load the data, and I use the subject number to index the name of the mat file. So I create a new string where the subject number is part of the name. So you have to check whether all the subject names and numbers, subject numbers are present in your data. I load them in. After that command, the variable data represents the data of that subject, and then I add the subjects into the matrix in the next column. So I run the for loop on index 1 up to the length of the subject, which means that subject number 7 in this case will not go to the 7th column of the reaction time matrix, but will go to the 3rd because of the position in that vector. So that is a very clear distinction between running for S subject is 1 up to length subject or for subject. If you would have a for subject here, the data for the 7th subject will go into the 7th column. We saw that before. So if you want to plot the data in, for instance, plot the data for this reaction time structure that we have after we ran that, in this case for the 3 subjects, you can say histogram to have a histogram of the data. And there's a very interesting part of the plot that you see here, which we will address later. So there's this special lump of data that you can see at 0 here, which is probably interesting if you look at the data from a scientific point of view, because they are probably response times that are not really 0. So another way to look at this is to look at the raw data, just plotting the response times as raw data. I will also look at these. So you can see that, especially in the beginning of the data, there are some response times that are coded as 0, but are probably non-responses. Non-responses are usually coded as 0, but they give this weird thing that if you calculate the average response time, it underestimates the response time because missing values will be coded as really fast responses. So what you want to do with data like this is to recode them as zeros. Recode these zeros with the MATLAB constant NaN, which stands for not a number, because a response time that was not given has no response time. So the way to write that down is saying I want those response times for which the response time is 0 to be changed into not a numbers. So if you do this, you can calculate you can replot the data if you would like. So if you do it like this, you can see that the zeros now are gone. If you calculate the mean now of the response time, you will see that the response time means now are all not a number, which is mathematically correct, but which is never what you want. The average of a vector which contains at least one not a number is always not a number, mathematically, but usually we just want to ignore them. We just want the average for all the numbers that are there. MATLAB, thank God, has a way to do that, and that's just by adding the flag omit nan to the mean function. So if you do that, you will see the means are calculated without the zeros and without the nans. Okay. It would be really nice to create a bar graph of the response times of each subject. I'm going to do that with the command bar, which you can easily do on the response time numbers that you calculated. So if you say I want this to be calculated, you can see, oh, I want it like this, sorry. I was a bit ahead of you. You can see the three response times. The quicker response time is in the middle, so that would probably be the reddish response time here. And you can label this nicely, and then you see that subject number is on the oh no, it's actually not subject number on the x-axis, it's subject index, and the mean reaction time is on the y-axis. I say that this is subject index because the third subject at number 7, as we remember. These plots are very informative, but one important thing is still missing, and that is the error bars. A lot of programs, statistical programs, allow you to do error bars. MATLAB does also. We want the error bars to reflect the standard deviation of the data. And we do that with the function std, which is not an std but is a standard deviation. And then we have to say omit nan again. I'm sorry. Omit nan again because the standard deviation of a function that has nan of data that has nans in them is also mathematically defined as not a number. But if we do it like this, you get the 3 values, and then you see that the third value is a bit lower, so probably the standard the third subject, 7th subject, was a bit more steady in his response times. So we now have the matrix or the vector RTSD, and we will add them to the plot, and you will see that we're almost there now. So you can see that the plots are there, only there are these lines connecting the bars. So that's not really what we want. So we replot the data and we set the line style of the arrow bars to none. Then you get the plot that you probably want. This is something that we want you to do in the in-class assignment for today. So take this code and have a try. Okay. I wish you good luck. And this was all that I wanted to tell you about.